Chapter 7. The Understanding Must Be Stretched. Francis Bacon has been called the greatest, wisest, meanest of mankind. With his wide-brimmed hat, starched ruff, and pointed beard, he was a brilliant member of Queen Elizabeth's learned council, and a persuasive orator in the Parliament. But he was sentenced to the Tower of London because of some financial irregularities, and was forced to spend the latter part of his life in retirement. From our point of view, this enforced retirement was not a bad thing, for it gave him leisure to write his great and influential book, the Novum Organum. It has been said that this book was written, quote, with a magic pen, unquote. Francis Bacon was what was then called an amateur, one who loved learning. He was a philosopher and a scientist, and he thought, as did everyone else at that time, that science and philosophy were the same thing. In the Novum Organum, he wrote that no one could arrive at scientific truth by following blind tradition. The only way to understand a thing, he said, was to collect all the facts connected with it and let them pass through your brain as though as through a kind of mill. Scientific work for him was an enormous, patient work of collecting. Men must stretch their capacities, he said, to take in all the astonishing facts that lie around them. They had already invented the telescope and could begin to explore the skies. The compass helped their little ships to sail across unknown waters. They were beginning experiments with electricity. The world that they knew was filled with unexplained facts. That was why the scientists must stretch their capacities to take them in. Bacon wrote, quote, "The universe is not to be narrowed down to the limits of understanding, which have been man's practice up to now, but the understanding must be stretched to take in the image of the universe as it is discovered." Unquote. Perhaps in writing this, Francis Bacon was merely giving voice to the spirit of his time, for here and there, everywhere through Europe in the 16th century, the scientists were at work. Most of them had no special training and did not hope to gain any practical benefit from their work. They were following their scientific studies merely for the sake of understanding the world that lay around them. Often it must have seemed to them that they could make more progress if they could exchange their ideas with others who understood their problems. But roads were bad and traveling hard in those days, and there was no dependable mail service, so most of the scientific workers had to get on as best they could alone. However, certain rich men who were interested in scientific discovery became patrons of science. Sometimes they invited several scientists to come and stay at their houses so that they could talk together. Sometimes they encouraged them to write long letters about their work and had these copied and sent around to large circles of interested people or read to interested groups. One of these patrons of science was William Gilbert, Queen Elizabeth's physician, who was himself an experimenter in electricity. Nicolas Fabry de Pirasse, a very learned man of France, was another. He seemed to know every scientist in Europe. People said his enthusiasm for finding out nature's ways had no limit. A Minaret friar who lived in a cell of a monastery near Paris was also a patron of science. His name was Marin. Marin, a very skillful writer who knew very many languages, translated scientific treatises so that scholars of many nationalities could study them. Learned men from all over Europe came to Marin's cell. Among them was René Descartes, the famed French philosopher, and Jean-Baptiste Colbert, who was later Minister of Finance under Louis XIV. And there were many others. The little group formed one of the first learned societies in Europe. Gradually, the number of such groups or learned societies grew. After a while, whenever a scientific discovery was made, it was reported to one or another of them, and scientists counted it a great honor to be invited to come to address the members. One of the most important of these societies was the Royal Society of London. Before long, the societies began to publish their proceedings, and scientific journals were printed and sent to the members. Such journals started in the 17th century when Denis de Sallo employed a staff of men to copy passages of what he thought the most remarkable scientific writings. When the French Academy of Sciences was started, de Sallo suggested that it take over this work, and this was done. For a long time, a man named Henry Oldenburg was secretary of the Royal Society in London. He was very enthusiastic about having the society publish a scientific journal. He wrote, quote, "As there's nothing more necessary for the improvement of philosophical matters than the communication to such as apply their studies that weigh such things as are discovered by others. It is therefore fit to employ the press to gratify those who delight in profitable discoveries, doth entitle them to knowledge of what this kingdom or other parts of the world do afford, as well as the progress of the studies, labours, and attempts of the curious and learned in things of this kind. Such productions being clearly and truly communicated, desires after solid and useful knowledge may be further entertained, ingenious endeavours and undertakings cherished, and those conversant in such matters encouraged to search out new things, impart their knowledge to one another, and contribute to the grand design of improving natural knowledge." Unquote. So before the end of the 17th century, the scientific societies were flourishing. Investigators were reading the scientific journals avidly. But another movement helped men in their, quote, ingenious endeavors and undertakings, unquote. This was the establishment of scientific museums. The first of these was founded by the Royal Society of London. Back in the 3rd century BC, the Museum of Alexandria, which was a famous center of learning, had included a school and a library. But although this new museum, which the Royal Society was founding, included a scientific library, it was mainly intended to house specimens on which the scientists could work. It was to have carefully collected and prepared plants, bones, dried fish, shells, and such animals as its curators or caretakers wanted to preserve. Preserving the specimens was difficult. This was especially true of the animal specimens, for animals lost their shapes and colors when they were dried, so that it was impossible to make satisfactory studies of them. To meet this difficulty, the eminent Irish scientist Robert Boyle, who was one of the first members of the Royal Society and who had done distinguished work in chemistry, suggested that specimens might be preserved in alcohol. Since then, every biological student has been able to see specimens so preserved. The specimens preserved in alcohol were usually kept in glass containers, and the early glass was of such poor quality that it was difficult to see through it. But in the last quarter of the 17th century, a new kind of glass was made. It was a heavy, brilliant, crystal-like substance made of lead potash and sand. Since powdered flints were used to make the lead potash, it was generally called flint glass or lead glass. So in the rooms of the Royal Society, biological specimens preserved in alcohol and contained in glass vessels soon multiplied in number, and these have been part of the equipment of biological laboratories ever since. Since alcohol and flint glass were both rather expensive, another device for preserving animals was soon discovered. This was by the injection of certain preservative substances. Soon the museum which the Royal Society had established was copied in other places. France, Germany, Holland, Italy, Switzerland all had their museums where shelves bore rows of glass vessels containing specimens preserved in alcohol, where birds and butterflies and insects were preserved, and dried plants, carefully mounted, lay ready for the scholar's penetrating eye. In Versailles, through the bounty of Louis XIV, one such museum was organized. An old French engraving of 1671 shows a picture of it. The Grand Monarch, in plumed hat and silken hose, stands with Colbert and the other French savants, their specimens around them. Hanging on the wall are the skeletons of a man, a stag, an antelope, and a lion. On a shelf are glass containers, presumably holding specimens preserved in alcohol. In the right-hand corner is a stuffed civet cat, and there are numerous other objects that may be useful to these gentlemen in their search for the understanding of natural phenomena. On the table just before the king is a microscope. He must be talking to Colbert about it. His hand in its great silken cuff is pointing to it.